Hello and welcome back to the next episode in our factory building series. So in the last episode we touched upon the miner. There's a lot of work going to be done on that yet, but you know it's kind of working, so yeah, no problem at all. But what I did find was our builder tool didn't work with it. And that's because even though I put a few options in there to allow for what grid size it takes up, it didn't really work too well because I've done all the coding and only worked with one object, which was our old Jenny here. The actual code didn't work very well once you started making items that were double the size. That's because them being double, there's no center square. So this would just paste onto the center square, where a double one would want to sit across the three sort of here, and I wanted to try and keep them locked to a grid. So I had to play around with some of the code, and I've changed a lot of it. So that's what this episode is going to be about: a retouch and a walk through what I've actually changed. I'll just show you now this running so you can see. If I press number 2, as you can see now, we have our lovely miner moving around, and as you can see what it's doing, it's snapping to the left hand side of the cursor rather than the center, because it can't snap to the center because there is no center. It would mean it would overhang, and that's what was happening. And there was also a misalignment of the box collider, so it took me a bit of while working way through, which is probably a better idea because I can talk you through it rather than you sit through me fumbling and stumbling over code that had to be reworked and changed. But as you can see, bang, there we go. Can't overlap it. Yeah, but we can put it in front of it, not a problem. Yeah, so they're always going to be to one block, and it works with this as well. I've already tested that it works with this. So the idea was, as you can see on this grid, anything with an odd number on its width, so 1, 3, 5, 7, 9, etc., it will line up to the center will line up to the cursor. So if it's 1 wide, it'll sit there. If it's 3 wide, it'll go 1, 2, 3, and this will be where the cursor's pointing, so it'll straddle those 3. I tested that by forcing that to look like it was 3 wide, which I'll show you now. Let's just go into our, not the generator, we want the miner, and we're going to set this to 3 width. Yeah, so remember it's length, width. Okay, and now you watch it not work on me now. Let's go in and hit 2, and now as you can see, the bounding boxes are thinking it's 3 wide because we've told it it's 3 wide, but it's not. But as you can see, it's now sitting on the center. So if it was a 3 wide object and it took up 3 spaces, the center of it will sit there. Yeah, I hope that was a little bit understandable. Let's put that back to normal. So let's compile that. We'll go back now to our builder tool. So what's going on in here? There's quite a fair bit's going on in here, and as you can see, there's probably some functions missing on here. I've gotten rid of them, and I'll show you what I have replaced it all with now. So here's the first function, and it's trace build position. I don't think this changed whatsoever. Okay, so this is probably pretty much the same. You might want to check a screenshot or pause it here and check yours, but I think that's pretty much the same. Spawn new build. Again, I don't think this has changed at all by the looks of it. No, it's exactly the same. All I've done was change what in here, what I'm spawning with now. But apart from that, nothing's changed. So our first change is actually going to be in the tick event. So if we come to our event tick, we still do our parent tick, then we check that it's activated, then we trace our build position, which hasn't changed. Then I've put the validated get for the build actor, and I've put it here so that it's ready for use for other things. But as you can see, I've had to add this extra validity check here. Okay, I've actually hooked it up now to a branch, and what that's doing is checking is the build position valid, because if it's not, we don't want to see the actor, and that's all that's happening there. So we jump from trace world position, get the valid out, and that connects all the way into this branch. You know, let's make it a little bit easier for you to see. Bring that up, as you can see. So all it's doing is jumping into this branch and saying, well, if it's not valid, then let's hide it, because I've got to do the validation get first so that I can set whether it's hidden or not. And that's what I'm doing, and I'm setting the flag here to say valid placement false. Okay, we're doing our collision detect as usual next. That's changed, I'll go through that in a minute. Then we're coming across and we're setting the actor hidden in game based on the opposite of a valid placement. So if it's a valid placement, you don't want it hidden. I've actually swapped this around. I changed it around for ease of purpose last time, but it wasn't telling us true story. We was using it as the opposite of what it was, if you get me. So I've put it back to what it is. So this will say, is this a valid placement? If it is, then we don't want to hide it. So we're not hiding it. So we've put a not boolean in there. If you right click and type not boolean, that's what comes up. Yeah, all it does is switch from a false to a true and a true to a false. So we're checking if it's a valid placement. If it's not a valid placement, it comes through and we hide it. We set actor hidden to true. If it is a valid placement, when we don't hide it, we just switch it round to not hidden. That's all it does. We could easily just set another boolean and have two tick boxes just to say either or. I just think that's much cleaner. Build actor. We're now sending through the grid size here into a new get build position here, right? Now this new get build position I will go into, it's actually in a new section. I've actually created a blueprint function library, and I will show you that in a moment, and I'll show you how to build it. But that's what this is. The default grid size there, actually I really should use the proper one. That's something else I've got to show you, so that reminds me. So get default grid size, right? So I will show you that first. Once I've gone through this, I'll show you this first, how this is set. Right, so this is a new function, and we're sending in the actor size, the default grid size, because this may change, but I'm sticking with 100 probably, most likely. But there may become an instance where we might have to change it. We might want to use a larger grid. So I've just made this so it can be changed, that's all. And that's what this variable is, but I'll show you that in a moment. So the get build position is using the grid size. It needs to check the actor grid size as well. It needs a target position, which is fed from the trace position. So the trace hits the ground, that's the location. And then the rotation, based on whether it's at 0, 90, 180 and 270. That's what that does. It sends through the place rotation there. This was the same. So again, we've set the actor location rotation. So the build actor is now going in the output actor location that comes out of here, this new function, and the rotation is based on the place rotation, which is just, again, like it says, 0, 90, 180, 270. So default grid size, let's get onto that first. If we come into our game and BPGI, a game instance, yeah, this is where the default grid size is set. So it's just a variable, standard float, and by default I've set it to 100. Whatever changes there changes in the game. Okay, so this is an easy place, a one-stop shop to set that instance, yeah, and that's there. Okay, when the builder tool starts, I think begin play in the base. So let's open up the base to the tool, because this is where it's stored, in the actual base rather than in just the build. I'd have to copy it into all of them. So in case it needs using in all the tools, I put it into the base. So if I get to base classes, and no, it wasn't, it was the tools, wasn't it? And the base tool here. all I'm doing is on begin play, I'm getting our game instance by using get game instance. Okay, casting it to our instance type, which is the BPGI main game instance. Yeah, that's so I can then pull off here and do a get default grid size. Yeah, so remember, this is where we stored the HUD. We're now storing the default grid size, and we're then storing this default grid size in that variable inside the base class, so that regardless of which tool I've got open, I can right click and get default grid size. Yep, I can get or set it as well, but primarily get. Any tool can now get that grid size, just in case it's of use or anything. It might be useful for the dismantle tool. There might be like a box selection or something using a grid. It's possible. Not thought that far ahead, but that's where we're setting this for use. Okay, so what I'm going to do now is go into this collision detect. We had this before, and it used these two as well, but it's changed. So a lot of the code has been offloaded from here, and that including the checking the rotation and so forth, because that's all done now within these functions. But as you can see, the code on this has been reduced dramatically. So let's zoom in on this side first. I'll just concentrate on this part. So we get our actor and invalidate it. So if it's valid, we can get its grid size. Yeah, and we set it to a local variable, actor grid size. Okay, also in here we have some other variables that are no longer used, so let me get rid of those. So I don't want to confuse you, because these are no longer used. There we go, keep this nice and clean. Right, so the only variable we're using in the collision detect function is actor grid size, and it's a vector 2D. Yeah, so you just need to search for vector 2D. It comes up with the blue dot icon there, and we set the actor grid size from the build actor into that. So we've stored it so we can use it, because we need to use it twice. We need to use it once on our box detect start and once in our box detect end. I believe these were here before in the last one. I've just given them a few comments here. So basically this function finds the beginning of our box trace to detect whether we're allowed to place this object. Yeah, and all it does is take the position of the trace that we fired to the ground and the actor's grid size. That's all it needs. Then that goes on to the next, and then that returns a position for where the traces start, which will feed into here. But then we also feed that into the start of this box detect end, as we did before, because then we calculate from that position how far we need to cast the box forward. And this also needs the grid size, the actor grid size. It all become apparent once we get through. And what comes out of this is a position for the end of the box trace and a half size, which will give us the width of the box trace. So let me just show you the difference in the two widths. So if I go back into the builder spawn, and we'll change this to our generator. Yeah, so as you will see when we play this, that's number 2. Okay, so where my cursor is pointing is box start, so that's where the box collision starts, and the second box behind it, which I can't point at because it moves, but the second box it goes to is the box end. And basically it'll take the width and the length of the object and calculate where it needs to be, which I'll show you all the calculations in a bit. But that's what the half size is. This box trace itself uses let's have a look, let's get back into it, and there it is. It uses a half width, a half size, so it's basically a radius of the cube. So we need to detect that, and we do that by using the default grid is 1 cube, and we halve it to get our half size, and then depending on the width of the object. So if the object is 1 box wide, the half size would be 100 divided by 2, so half of it would be 50. Yeah, because 1 meter is 100 units, half of it is 50 units. The half size would be 50, but we need one for each way, X, Y, and possibly Z. At the moment I'm not using Z, as you notice I'm not going very tall with them. That may change. That's quite a simple one, that one, because there's not so much calculation on that. So that's what the half size is, and then it draws the box trace as usual. But then all we've done is we've inverted the valid placement bit here, and again that's to make it common sense, because if this hits, right, that will come out with true, which means it's not a valid placement, so we invert it. So a true hit is not valid, so we set valid to not valid. Yeah, if it isn't a hit, it will set it to is valid, so it'll change the not to true, the false to true, and it is valid. So we're using it in its proper manner this time. I should have really picked up on that when I did it, but like I said, I'm coding this as I go along. So yeah, basically that now is setting correct. Valid placement will give true or false. Valid true, not valid false. So let's start at our box start, or box detect start. Now this is a little bit more complex than what it was, but it's changed a little. So I'm going to come inside here, and I'm just going to show you. Even though there's nothing coming off here, it's still being used here, because you can, because it's there, it's classed as a variable, so you can still go get actor grid size, like so, and that is an extension of that. All this has done is I've right clicked on the pin and I've split it. That's all I've done. So that looks the same now. Yep. So even though it looks like it's not connected, it is here. So this is where it finds out where the start of the box detect is. Okay, I'm not going to go into this just yet because I want to show you the functions I've made. So if I come back to box detect end, again, this uses the grid size. Again, we've just pulled it out, so I can probably collapse those pins because let's recombine. You can see grid size is still there, but I've split it there like I did in the last one. Okay, and now as you can see, it looks a little bit crazy here, but I'll show you this in more detail on what it does in a moment. So this is what I've also done. I've come into the game folder, I believe it's the game folder, yeah, and I've created a new blueprint function class. So if you right click, blueprint function library, yeah, click that and it creates a new one of these, yeah. And in here I've put in the related things we need for all of our buildings. So when you first open it, it'll have a function ready to be made, because it needs at least one function in there, so you can rename it and change it to whatever you want. Okay, so at the moment I've only got the building type stuff in here, but this can hold a lot more. Like for instance, this function here is just a basic math function. It's not linked to just building, and I may have to use it somewhere else. And what this does is just, it basically detects whether a number is odd or even, and to do that, all it does is it comes out, truncates it, which makes it an integer. So if it's 1 point something, it's now 1, or 2 point something, it's now 2. Yep, so it returns an integer. And then you use a AND, it's a bitwise AND, which ANDs all the values together. And then what it does is checks to see if the result of this AND is 1. Yeah. If it's true, the number is odd. If it's not true, which will be 0, the number is even. So the output is odd. So it'll be true if it is odd, or not true, false, if it's even. Yeah, and that's all this does. This value passes all the way through for ease of purpose. See there, all we're doing is sending the same value back out the other end so that it can just be used later on. And I'll show you that in a bit when we actually use it. So just so we don't have to come all the way around it again with this value. We just output it here, just makes it easier, that's all. So what are we actually doing in here? So let's use the get build position. I'll go through this as we go. Again, we're using the actor grid size in here, which is just split using the get here to get it off there, and we're just splitting the struct pins so we can see the individuals. Okay, and the build position needs a target, it needs the default grid size, it needs the actor's grid size, and also the rotation of the object. It comes through and does a load of work to actually calculate the beginning of the grid. So how's this working? Let's walk through this step by step. So first thing it does is it finds the grid, just like we did before. So if we get to grid center, now this one is doing two at once. Yeah, so first I'm getting the X grid value, then I'm getting the Y grid value, then I'm outputting it here using a make vector over here. So as it's a sequence, it'll go to there. Once it finishes, it'll go to the then 1 and then 2. So in this we need an X, Y and Z, which is basically just the vector of a line trace that we send to it, and the grid size, which is our default grid size. Yeah, that's coming through to here. And I don't actually think we use, oh yes, we are using the default grid size because we use it inside this calculate grid. So basically this function here, calculate grid, will work out our absolute grid position. So it'll go from 100 equals grid 1, 200 equals grid 2, and so forth, like we was doing before. Ignore this world context. It's something it adds in there when you use a function locally within a function library for some reason, but you don't need to set it. So ignore it. It's not important. We don't need to use it. Okay, just it's not causing me any errors or any problems. So it calculates the grid position for X, adds it into a vector, creates the Y position, and then sets the Y position. The Z just passes all the way through, yeah, all the way through from there to the make vector, and then we return the new vector out, which gives us our two grids. Okay, as you see there, Z is unchanged, it just comes straight through. So to calculate the grid, this is what we did before. Yeah, all I've done now is I've took out the hard-coded values. So I've no longer got the 100 in here and the 50 in here. I have just got the grid size, which is being passed through. So we get the grid size and we get the value and we divide it. So if this was 200 and the grid size is 100, we divide it, we get 2. Yeah. If there's a percentage involved, we floor it like we did before. So it rounds it down to the nearest integer, and that gives us our corner position. We then times that again by the grid size to get our absolute corner in units. So we've gone from a float number, which could be, I don't know, 180 say. We've then divided that by the grid, which is 1.8. We've then floored it, so it's now 1. We then times that by 100, which is our default grid size, so it's now 100. Yep, so the corner of the current square that it's in, the grid square that it's in, is 100. Yeah, if you remember our whiteboard, we showed how the grid coordinate system works. So it's just the same thing again. So now we have the 100 as the base corner. We then need to add a bit of a modifier onto it, and that is because the position it's given is right on a line. We now need to move it so that it's the center of the object is not on a line. We want it at the start of a grid box. So say this was our grid. This position here coming out is giving us this line. Yeah, so that means we're placing that object right in the middle of this line, which we don't want to do. So because it's in the middle of this, all we do is move it across to the nearest whole line, so it will be the center of here. So the object will be centered in a whole grid rather than on the line of a grid. And to do that, we just divide the grid size in half and add it on. Yeah, and that's all it does. It just adds on so that it shifts it off the line and into the full box. So the box won't be, instead of the box being like that, it's now like that, matches the grid. So that's all that does. We've done all this before. It's just before we had a times by 50, but all we're doing now is dividing the grid size by 2. So 100 divided by 2 is 50, and adding it on and returning it. So that's what happens in Grid Center. It gets the X value and it gets the Y value. It finds the center point line of the grid, yeah, the bottom corner, but then it shifts it so that the object is centered here and begins here. That's all it does. It begins there, centers here, and that's all it's doing. It's the same as what we did before. I've just put it in here to make it a bit cleaner. Yeah. Okay, so let's get into our get build position. So now we've got our grid center and it's returning out the X, Y, and Z. Yeah. We now have our X and Y position here to center our object on, and this same thing will be, it depends on the width of the object, but this is what all this offset stuff is about here. So now I've added in a new function called get rotation. Now before, if you remember rightly, we had checks like if rotation equals 0, if rotation equals 90, if rotation equals 270, if it's 180. Yeah, I've changed that now to this. I've created an enum so that we can switch on that enum, and I'll show you the enum now and I'll explain what I mean by switch. So in the same folder I've created this build rotation, and all I've done is each one give them rotation 0, 90, 180, 270. Yep, it's just an enum build rotation 0, 90. You could just put the numbers in, it's whatever suits you. I've put them in there for clarity. So this function here, get rotation, does exactly what we did before. We compare it, the value coming in, the rotation value, with 0, 90, 180 and 270. Whichever one it is, it will set this enum to the correct value. So if it's rotation of 0, we output enum rotation 0. 90 is rotation 90, 180 is 180, and 270 is 270. It should never ever be anything different because we're controlling the code. Okay, and that's how we've set it. We can rotate only at 90-degree intervals, and that's how we've set it. So all it does is then returns this value out. Okay, so this rotation value that's set, it'll find the first one, set it, then come here and return it. So it's a local variable, rotation value, and it's set to E. Can't really see it there. It's just E build rotation type. Yeah, that's all it does. So it returns which rotation it's on based on one of these enums. Okay, so if I come back into, sorry, that's not where we want to be. If we come back into our get build position, we can see it's outputting it. Yeah, it's coming all the way out and it's allowing us to check it later on, which we'll go into later or in a moment. So now what we do is we need to check how long the object is. So this here gets that, and then it offsets by a quarter. Now this might be a little bit confusing for you. Let's put 1 in there, okay, and I'll show you what this is doing. So as you can see, it's not lining up. Yeah, the object is not lining up, and that's because we're aiming here and the grid it's getting doesn't match up with the size of the object. So we force it by getting its X length and times it by a quarter. Yeah, 0.25. If I show you 0.5 for now, actually, 0.5 I said, there we go. I'll show you what that's doing. So if I then, it's only because I'm putting this in, it's harder to show you without it. There we go. It's centering on the wrong box. So we are a quarter out. As you can see, there's a quarter of the object hanging off the back side. Yeah. So it's not half. It's a number I had to play with, to be honest, until I got it right. Let's go back into the functions. So if I set this back to 0.25, okay. Now this offset is added at the end. I'm just going to let's get rid of this offset. Okay. Some of them need positive offsets, some of them need negative offsets. So let's see what happens when I remove the offset so you can understand what's going on. As you can see, it's centering itself on the first cube, yeah, which is wrong. It needs to center itself on the second cube there, yeah. It needs to center between and it's to center back. Now if I moved it by 50%, it will be overhanging the other side as well. So as you can see, it's roughly a quarter of the way over the line. If you take into account the gap at the beginning and the end, it's roughly about a quarter of the way over the line. Yeah. So that's all I'm doing. I'm adding a quarter on it so that that sits in the box properly. That's all it does. It was a number I had to play about with. It turned out to be quite relatively easy once I figured out it was a round number. It was just a quarter of the movement, and you could, if you look at it, you could see there's roughly about a quarter hanging over each side. Okay, so a quarter of the box. So I wanted to move it back, but I only want to move it back by a quarter. So let's go back into here. So let's relink these back up. So some of these need positive offsets and some of these need negative, and I'll go into those in a minute, just showing you what I've done. Don't worry, I will go over this section as well. So that's what this offset does. It figures out the length, it quarters it, so that means that the object is then exactly halfway between the start and the end of its bounding grid. So if it's only 1 cube deep, it will sit 1 cube deep. If it's 2 cube deeps, it will sit bang in the middle of the 2 cubes so that they overlap equally halfway. Okay, you just have to take me on this one. There is a reason behind it. I did do all the maths, but it's been a long day doing all this. So now we have the Y size. Now this is the width of the object. Now on the generator base, it's only 1 unit, so it doesn't matter too much. But on the miner, it's 2 units wide. So that means, again, we need to figure out where it's going to sit. Now, because, like I said, if I bring here, if we've got a 2 unit wide object, okay, I don't want it to straddle. When I point here, I don't want it straddling over here or over here. If I point here, I want the object to start here and then straddle these two. So then the 2 wide comes over here, so it's like 2 by 3 like that. But if it's an odd, I want it to just be like that. And then we need, that's why we're checking this here. We need to check if it's odd or even, because evens are going to start in the left cube and overlap to the right. Odds are going to center on the overlap cube. Yeah. So if it's 3 wide like that, I want it centered in the middle. But if it's 2 wide, I don't want it centered in the middle, which is this line. I want it centered, or I want it aligned to this one. So it'll then be these 2 boxes. Yeah. And that's why I need to detect if it's odd or even, so that I can set whether there's a width offset. And all we do is get the grid Y. Again, we times it by the grid size, and then we divide it by 4, which is times by 25, 0.25, sorry. So 1/4, and we only use that yeah, if it's an even. Yeah, and let me just put this back in. If I don't set this, okay, and I change my spawn to the minor, there we go, save that. If I run this and if I hit 2, as you can see, it's now balancing across the middle of that box. Well, that's what an odd one would do. I don't want an even one to do that, because as you can see, it's taking up 3 squares for the 2. If you look at the actual, oh, you can't once you've done that, can you? I forgot about that. I was trying to see if I could point at what I was doing, but if you can see from the grid collision box, it's in the right place. I want it to start at where I'm aiming at and go over to the next box next to it, but as you can see, it's straddling 3. That's what this offset does. Hope that's understandable to you. So it just adds an extra quarter of a grid so that it starts exactly in a grid, which if I now run it, you'll see what I mean by this. There we go, it now starts in this grid rather than overhanging there, and it only fills the 2 grids, so we're not wasting a grid space either, but it settles right. And it also works when I rotate it. It will always be in the correct position. Yeah, it will always rotate that one spot. I'll show the rotation code in a minute as well, because again, a little bit complicated, that one. So if you get yourself a look at that, so it looks a little bit spaghetti, but if you're just careful and watch it, you should be able to link those up. So basically we're getting the default grid size into here with our maths. We're only using the size of the X and times by 0.25. All you need to do is click add pin if you want to add another one on the end, yeah, and remove pin. Yeah, so just click add pin to add some new inputs. Yeah, the input goes into a local variable called offset. Yeah, and that's all it's doing. So we've now got our offset, and we've now got our width offset, which is this one, which is the Y size. Again, same calculation. We're dividing the Y by the grid size, and then we're timesing it by a quarter to shift it just that little bit for odd numbers only. So if it's odd, it will come out as true, it doesn't set it, and if it's false, it will only set the offset if it's an even, not an odd. Yeah, we don't get the offset with an odd, we only get the offset with even numbers. Yeah, I didn't actually use the out value in the end, but that was the reason for it, so that it can always just carry on if I needed to use it, but it's fine, it wasn't actually used. So now let's have a look. I'll get to this one in a minute. Sequence. First in the sequence does this, second in the sequence does that. The last then one is basically the output of the location. Yeah, the final location we want our object to sit in. This here is a switch. That value we set when we got the get rotation here, it comes out, travels all the way across here, and when you drag out of an enum value like so, you can type on switch, and as it already has a value on this line coming out of where we've come from, it automatically chooses the right one. Switch on E_build rotation. Yeah, and what that does is list all the different rotations that we've got set in that enum, and then allows us to run code off individual ones. So now what I can do using that, rather than going, so if this equals this branch this whatever, yeah, I can just say, right, this is 0 anyway, this is what we do on 0. Okay, this is 90, this is what we do on 90, this is 180, and this is 270. Okay, the reason we've got this is, let's load this up, and when we rotate the box, as you can see, it has a new orientation. It just now means that the X is on the Y and the Y is on the X, you see? So we need to keep track of that, and that's what basically this does. We find out which way it's facing, and then we alter the modification values based on that. And I hope this isn't too confusing, I really don't. So what we've done is on its default rotation of 0, we're going to offset the X. Yep. So this is the X here. So we're going to offset this to make sure that instead of straddling there, we're there. Yeah. We're adding that offset that we calculated earlier. Yeah. But if we're rotated round 90 degrees, so say it was the generator, which is a 1x2 box. When we rotate 90 degrees, we're now a 2x1 box. Yeah. And that's basically what these are doing. On the 0 and the 180 is an X offset. Yeah. So it's at 90 degrees, it's going this way. At 180 degrees, it's going down this way, but they're both still on the same X plane there. Yeah. So what we do, we set the X offset on the 0 and the 180. The only difference on the 180 is that it's reversed. Yeah, we move it negative rather than positive. So whatever the offset is, we add it on here. On the opposite rotation, we minus it, and that's all multiplied by -1 just takes the offset and changes it to a negative value. So if it was an offset of 200, it will now be -200. Yeah. So 0 and 180, same direction, different rotation. Yeah. So the X is modified on both. One is a positive, one is a negative, so that it lines up. Let's just show you that in practice. If I connect this to there and get rid of the negative, we should show you now at 180. So if I set this to default, that's 0. Normal. But then as you see, it's now going back the same way, even though we've rotated it. So it's gone outside of that bounding box. It's going to the left, where it should be going to the right, because it should be rotating around that center. Yeah. Which it's not. And that's all the negative value does. Base functions. So that one is negative. When we're at 90 degrees and 270 degrees, it's the opposite axis, Y, that we're now on. So instead of going that way around, we're now going that way around. So we have to offset that instead. It's the same offset. It's just that we need to do it on the Y and not the X. And that's the only reason I've got these two different variables, is so that I can use them on the output here. I can add them onto the location. That's all it does. So what we're doing now is setting the Y, because we're rotated 90 degrees. Same on that one, but it's negative, just like before. Positive Y, negative Y, depending which way it's facing. So this offset, it basically either shifts from there, from there to there, or if it's on the Y axis, it will either shift from there to there. Just lines it up with the plane. Yeah. We've also then got to check the width of the object and add an offset to account for that. Now, the offset on this one will be straddling a line. Okay, we do need it to straddle the line. So if it's going this way, I want it to sit centered on there. So centered here. Yeah, so halfway down the grid, so it's square on here, but here is the middle of the object there, because that's the object is centered. If you look at every object that you normally build, let's go into the viewport. If you come out, the default scene route is buried. Let's have a look at the generator. We might see it better on the generator. The default scene route, you can see that little thing underneath. That's the default scene route. Yeah, it's bang in the center. Yeah, the object is centered on the X and the Y axis. Yeah, bang in the middle. Okay, it's not slightly to the left, it's not slightly to the right, or vice versa, or front and back. So that's all we're accounting for here, is we're moving it back so it straddles the number of boxes it needs. So if it needs 2, like this one does here, it will straddle 2. If it needs 3, it will straddle 3. And we can show you that working. If I change this back to the generator, this will compile that. And if I set now, let's just show you the outcome as normal. So that's the normal. Yeah, it's straddling these two boxes. Yeah, bang in the center of them. And if I now go into the generator and tell it that it's 3 long, yeah, it will then straddle the 3 instead of the 2. But obviously there's a few offsets on the size of that. But it'll straddle 3 instead of the 2. So let's go back into a generator. Sorry, did I put that on the wrong one? No, I put it on the right one. That's fine. Okay, so that just allows it to kind of center itself out and balance itself out across all of its grid squares that it needs. Okay, so that's what those are for. If you weren't sure before, these are for how much grid squares it needs to take up. And it's 2 long by 1 wide on that one. Let's go back into our base function. So, and that's all this is doing now. It's centering across its grid using 0 and 270 are positive values. 90 and 180 are negative values. And that's all this is doing. Times by -1 makes a negative value. So now we have our X and Y offsets. So obviously if you can see here, this is an X offset, that's a Y. That's a Y, that's an X, that's an X, that's a Y, that's a Y, that's an X. Don't get two the same because it will mess up. And I did do that. You know I did that. Okay. It then goes on to this return node, which is fed by the location of the grid. It comes out. We add the modification on the X and Y. We're not modifying the Z, so we leave that as it is. And we output it as a location. And that's all this does. I know it sounds and seems extremely complicated. Let's zoom into that so you can see that a little bit. I'll leave that on the screen for a sec so you can get a look. It does seem like it's very complicated. It's not. That's why I've put these comments all over it. So if I show you this one to here, yeah, just make sure you follow the right lines if you're going to do this. You may mess about with it yourself and find a better way of doing it. And then we've got this piece here. Okay. And then obviously the last piece, which I've already shown you. So that's there is the grid position that we are using in our, where was we? In our builder tool, and it's our collision detect. No, it's not. This is our event tick. Okay, so this now is in there. There we go. So we're back into our tick event. So we've done our check if it's a valid condition. We've popped out here if it's not. We've checked if our collision's working. Yeah, we'll go into that one in a moment. But I think I've already gone through most of that, but we'll go through that in a moment. We're then setting whether the actor should be hidden or not, depending on whether it's a valid placement. And then we use the grid size here and the actor grid size, its target position, which is the trace position, and its rotation to use that to feed into that get grid position. And all it does is come back out and sets the actor to that location. So when it comes back out of this function here, the values of these offsets are added to the original position and it's fed into this here. That's all it is. Comes out, fed into the actor location, and we set the rotation using the place rotation, yeah, as we did before. That's all that's doing. Yeah, that's as simple as it gets. The collision detect was a little bit more of a pain in the butt. This one took me a while to actually fathom out. So I had to rebuild the box detect start, the box detect end. It's pretty much the same code, but I've put most of it inside here. We had a lot more around here doing doing rotation checks and stuff. So let's go into our detect start. So as I said, we get our actor, make sure it's valid, we get its grid size, we feed both the grid size and the trace position into the start and the end, and we feed them into a trace by channel. We also get a half size, and then we set the value to not the hit value, so it gives the opposite. So if it's a hit, it's not valid. If it's not a hit, it is valid. Yeah. So, and all that does is control whether the actor is visible and placeable. That's all it does. So let's go into the detect start. Yeah, this is a little long-winded. Not as much as that other one though, but it is a little bit. Again, we've got some modifiers and offsets and stuff. So we start by getting the grid center like we did before. So we're getting this direct now, this grid center. As you can see here, we're not using the build position. We just want the grid center on this one. Yeah, so we're going to grab that using this function. So we've come in here and we've grabbed this grid center, and all it does, it works out what the grid corner is on the X and Y and returns it, just like we did before. So we get a grid center and we're sending in the default grid size. We get the rotation again based on the place rotation value. Yeah, which is changed via our Q and E keys, isn't it, when we rotate our build. And then what we do is first offset we need to create. Again, we're using the default grid size against the Y. Why? I don't know why. Because this is the width of the box, I believe. Let me just double check on my offsets. Let's see where that's going. No, this is the start of the box. Sorry, it's the half size is done in the box end. Sorry. Okay, so we get the grid size of the Y axis. Yeah. So this is its width. All right. Now the reason we're using direct to this grid center is because we do need the grid center on this one, because the box doesn't start in the bottom left hand corner. It starts in the center of itself. So we need its exact center. So we get the grid size on the Y and we times it by whatever the default grid size is. So in this case the generator is 1 on its Y. Yeah, it's 1 width. So this will be 100 times 1, and then we divide it by 4. Now why I've used divide it by 4 here, I don't know, but in essence I should do it exactly the same as I did before, just to keep it consistent. So if I multiply it by 0.25, okay, so we compile that. Okay, so we've got our first offset, okay, for the center of the first box, because the way it works, the box centers on the line and then creates a half width that way and that way. It's really crazy the way it works. So instead of starting there and going this way, it starts here and it has a half there to the half there. Use a radius. Okay, we then jump into a sequence. Okay, the then one again is basically adding everything together and returning it, but we'll go through that in a minute. So again, we check, see if it's odd, and if it's odd, then we do offsets based on the rotation. If it's not odd, we don't set any offsets. We don't need them. And let me just show you, if I delink that, okay, and then we come in here, so without any offsets, that's odd. It works fine anyway. Oh, this one will work anyway because of the size of the box. Let me change that to let me get this spawn, and there we go. Change that to our minor. Save that, and then we can see what it means. So okay, this will prove now, because the odd, we don't add any modification, so it's going to work straight off. But now we've got an even, so let's have a look. But as you can see, it's centering right on this box, but we don't want it to. We want to actually center it there on that line, back to where we was before, but the opposite to the box. We want to center it on the line, not not here. So that's what that offset does. Where was we? We was in the builder tool and we was in text start. So that's what this offset does. Again, it just shifts it by a quarter of an object, of a grid box, to make it match. And we only do this if it's even. So if it's odd, true, we don't need to add any modifications. It jumps off, adds 0 because these are actually 0. Yeah, these are zeros, 0, 0. Yep. And it just sends the value back straight through because we don't need to modify it. But because we have evens as well, we have to add the modifiers on. And again, all it is this offset we made earlier, the quarter offset, the quarter of a grid offset. And depending on what rotation it is, if it's 0 and 180, we set the offset to the Y. If it's on 19270, we set it on the X, because obviously the box is rotating. So because we're dealing in world positions, not local positions, we need to change it round. Even though the object's rotated, the X becomes the Y and the Y becomes the X, if you get what I mean, in world position space, not in local. So the first one is a positive, the last one is a positive, but the middle two, the 90 and the 180, are negatives. And again, that's what this -1 does. It just inverts the offset to a negative. So that'll be, so if that was 25, that'd be 25, but that'd be -25, that'd be -25. Yeah. Okay. So basically we just take the grid's output and we add whatever modifiers we may or may not have set, and then we add a modifier to the Z, because the boxes default to halfway through the floor, zeros. So it'll be half of, because it uses a half size, it doesn't sit above the ground, it sits half under, half up. So all I'm doing is raising it by 50 and 1. The extra 1 is so that it doesn't hit the ground. Yeah, that's the only reason. So now we send that back out as our box trace start. Yeah, so we've got our box trace start. We now send that to the box trace by channel start plug, but we also send it into the end, because we need somewhere to start from before we can work out where our end is. Yeah, so we'll look at that next. So in it comes again, and again this is all to do with the return node, so we'll look at this in a moment. We get our rotation again, okay, and this time we're not too fussed about whether it's an odd or an even now, because this is just where do we end the box trace, okay, and how wide is the box trace. So the first is that get rotation again, returns our enum telling us which direction we're in, just so we can split out and break out again into this switch. Okay, so we come out and we set the modifiers for the X and Y either positive or negative based on the object's X size. Yeah, -1, because otherwise you'll be getting 2 where there's 1, and so forth. So it just reduces it down, so because we're already, the box collision creates a box by default, so it will create a box by default. So we need to find out where the next box will be. So we ignore the first one, that's why we use -1, and we just get the next one, or however many there are. Yeah, so if X is 3, we -1, there will be now 2 times by the grid size. Yeah, so if it's 1, yeah, we -1, it's 0, because there's already a box here. This is the start of the box collision here, and if the box is only 1 tall, we don't want to add another box, we just want the 1. So we're not going to do an end position, we're just going to create this box. Yeah, because it's got a half size, it's already creating a size. I'll go into the half size in a minute. So we'll create automatically 1 box. If we want 2 boxes, we've already got the 1, so the end position needs to add 1 more to make it 2. So if this is 2 and we had 2, we'd end up going to 3, won't we? 2 plus 1 is 3. So we take 1 off and multiply it by the grid size, and we add that offset to positive on the X, positive on the Y for the 0 and the 90 degrees, and then negative on the X for 180 and negative on the Y for 270, just using this times minus 1. Now what we need is the half size of the box, and to set this, we take the Y. See, this one was using the X, so we take the Y grid size, yeah, and we times that by the default grid size. So this one is 1 wide times by 100 is 100, yeah. So the grid size will be 100, but 100 as a half size, yeah, that's 100 if that's a half size. But if you add that is a half size, you'll make 200 square, yeah, because the half size, yeah, is a radius. So as it's starting from here, yeah, we need to double it. We need to halve it, sorry, yeah, so that we get, do you know what, I'm completely lost for words what I'm saying. I don't understand it in my head, but I'm completely lost for words what I'm saying. Yeah, we need to halve it because we don't want the full size of the box. We want the radius, yeah. So we only want from there to there because it does both sides, and it does front, it does back, and it does top, yeah. So we only want half of the size of this grid because it will automatically account for the other half. So that's why we've divided by 2. Well, times it by 0.5, which is divide by 2, yeah. So the grid size times by 0.5, so that halves it, and we set our half sizes then. And all our half sizes are the same all the way down, yeah. But we're only doing that based on the Y, yeah, because on the X it's just a movement across. But as you can see, it's Y, X, and then X, Y, X, Y. So always make sure that your half sizes here are set Y, then X, X, then Y, Y, then X, X, then Y. It looks confusing because you're thinking, what's it doing all these for? It's only going to do one of these depending on the rotation, yeah. So it puts its modifier in for the end position, so where it's going to end, and then we set the half the size of the box, yeah. Now, as the Y size can be bigger, that's why we're multiplying it there to the grid size and then halving it, yeah. But the opposite way, we're just going to go grid size at a time, aren't we? But again, it's in half sizes, so it gets really confusing. So all we do is times the grid size by half, yeah, to do the other side of the box. Okay, so let me just put that as a 1, and let's show you this working. As you can see, it's making too big of a box, yeah, way too big of a box. Okay, it's just way too big. It's double what it needs, basically. Yeah, if you look at it and you work out by counting the grids on there, it's exactly hanging over by 2 halves, 1 at each end. So it's actually half a box too big. Yeah, so it's actually, instead of 3 deep, it's actually making it 4. So that's what this part does here. We halve the width that it's adding on, and then as you can see, it does 3 cubes. So instead of 4 like it was doing before, it adds the 3 cubes. And the width is set also, again, as I say, by these half sides here, depending on the width of the box. So if the width of the box is 1 times 100 times half, it means half the box size is 0.5, which is from there to there, but it's half, it's doing half width, it's a radius. I wish they'd put radius in there rather than half size. So if I just put, say, how can I do this without mucking it up? Let's just put that as a 1 there, so I can show you the other way around. So if we don't put that modifier in, look how wide it is, yeah, because we're now telling it it's a whole box is half its width. So we're telling it 100 units is half its width. So it's now doing 400 units, where we don't want that. We want it as half its width, not as the full width. That's why we use this here. We divide it by 2. Save that. Okay, I'll leave that there on the screen for a sec. Let's bring it out a bit so you can see it. And this one. And then it comes down to this then 1, which comes out of the start vector. And then we just add this modifier, X modifier and Y modifier. They're just 2 float variables that we're setting here using this. Yep. And then we send back the half size. Now the half size on the Zs is always going to be 50. I might change that later on, but we've got the option to do it. It's there, and we may or may not need to do that, but let's have a look. So we send our half size back. Yeah. So then when we go in to our collision detect, the half size comes in here, and the end comes in here. So it comes to here at the end, and the half size of the box is set by the half size that we set within the detect end. Yeah, and then it returns the opposite of whether we got a hit or not to say whether it's valid. So we've gone through that, haven't we? We know what that means. Yeah, so that's what it does in a nutshell. Now that was a very long video. I know it was a very long video. And I apologise for it being so long, but it was a lot of work I did off camera. I've spent a very long time today doing this, so it may not have come across perfectly well. Let's go back to the event tick, but I'm hoping now that you can understand it a little bit better. If not, again, there is a Discord. If I'm not around, leave a message on there. I will reply, or leave a comment on the video. If there's something you need to see, a recap or something, I can do a separate video for a recap. But it's basically, in a sense, what we had before, but I've tidied it up, polished it up, and it's now working as intended with whichever size object you wish to place. And as you can see, the collisions all work, and we can place them. Yeah, there we go. And let's rotate one round and let's put one there. Let's rotate one round and put one there. We can rotate one round and put one there. Yeah. So, yeah, it's working. It wasn't quite working before. It was on the generator, but the generator is what we originally worked to when we made it. So, of course, it's going to work. So all them offsets and things that we did before seemed were probably more specific just to the shape of that one. Just that one object, which obviously did not work once we started playing around with it, did it? So that's why I had to change it. Maybe using a blueprint function might not have been the right way to do it. I could have probably kept it in there, but hey ho, it just keeps it a little bit tidier on the builder side here by calling it the other functions. As far as I know, I haven't changed anything else. I think I've covered all the extra variables that I've put in each. Like collision detect has just got the actor grid size. The start detect has got an X modifier, Y modifier, an offset, and a half width, which I don't think we use the half width. So let me just tidy this up and get rid of that, because I don't think we need it. No, we don't. So let's get rid of the half width. Delete that. So an X modifier, a Y modifier, and an offset value. Yeah, that's all we needed in there. They're all floats. Go on and save. And the end again has a X modifier and Y modifier for positioning, and a half size for the X and Y for the actual box itself. Yeah, it's not as complex as this looks. It really is simple. Once you get your head around how it works, it really is simple. But again, if there's any problems, please just put a comment in. I don't want to leave you getting confused. I did have someone already come into the Discord channel with an issue from a previous episode, and I hope, well, he kind of sorted it himself in a way that I wanted to sort it myself. That sounds a bit strange. It changed the way the power propagated down to the power cable, and it was in a way that I was probably looking at doing myself. It wasn't the same way I made it, but I want to take all the processing power off cables, so that all cables do are dumb variables, and that's it, and they're there for looking pretty and nothing else. So he did the same thing in a way of what I was going to do anyway, and that's put all the processing onto the generator to do setting of variables and so forth, and then let each object pull the variables from the cable once they're connected. So yeah, use the Discord. I will answer. If I can't answer straight away, I will answer. Put it in the open channel as well, because it might help someone else. Don't just send me a private message as such. Just put it in the open channel, because everyone can benefit then if others are having a similar problem. But as I said, there's also the comment section on YouTube. Please use it. If I can help you in some way, if it's something you're not quite, understanding, I will try my best to explain it. I'm not the best at explaining things, but I will try. Anyway, that went on for much longer than I wanted it to, but I wanted to make sure you got everything in there. So I hope you got everything from that you needed, or if you're not following it that precise and you just saw something there that you like, and use it for yourself and modify it, great. This is what it's for. It's for helping everybody learn and maybe give them ideas on doing their own thing, which they might not have thought of before, where they might not do it exactly like I've done, but they might turn and say, well, wow, I could do it like this though. Do you understand? It's one idea can trigger another. So that said, I'm going to leave it there. So it's going to take me time to get this one edited and I'll get it uploaded. And yeah, I'll see you next time. Take care and goodbye.